Hey, folks, I really appreciate you guys doing the best you can. Appreciate Miss Roland for helping you guys out. And hey, I'm going to take care of you. All right. So this Friday, when I'm back, we're going to start. That's just the first page. We're going to do problems 1 through 4. And then when you return on Monday, we'll try to complete some more of the final exam. And then on Tuesday, we'll try to complete more of the final exam, and I think you'll be okay. All right. So, number one, when we're looking at a problem that has a right angle, you want to use SOHCAHTOA. Okay. So, SOHCAHTOA. That's what we're going to use on these problems. And I think making a drawing is really helpful. So, let's try to set up I'm gonna actually. I've kind of got them all in order in which you receive the packets, I believe. Actually, we're looking at the 2022 packet. So let me back up one page. So this is the first packet that you got, and the problems on all of these problem number ones are going to have a right angle in them. So let's make a little drawing here, and let me put my SOHCAHTOA back up there. Okay, so SOHCAHTOA. You're going to use this when you have a right triangle situation. So let's draw a right triangle. And I'm not so worried about, making the building look perfect or anything like that, but it does say the ladder will extend 20 feet, from 20 feet to 36 feet. If he wants a ladder to make an angle of 75.5 degrees with the ground, so 75.5 degrees, what will the smallest and largest distances up the wall that the ladder can reach? All right, so let's say this is the 20-foot ladder, and we want to know, what's this distance right over here? Well, this is the opposite leg. This is the hypotenuse, right? So we have the O side and we have the H side. So up here, which three have an O and an H in them? Well, the one I just put a little bracket underneath, right at the beginning, the O and the H. So I'm going to set up sine, right? So I want to go sine of 75.5 is equal to the opposite leg, which we're calling x, all over 20, right? Now, this is one where you're going to multiply both sides by 20. So I'm guessing this problem number one is not the main concern. Like, you guys aren't really panicking about problem number one, because as I do this problem, I hope you're going, oh yeah, this one's not so bad, right? Obviously, you need to have Desmos open. You need to be in degree mode, right? So let me jam over here to Desmos, and let's make sure we're in degree mode, right? So remember how you have to come up here to the little wrench thing and go to degree mode. And then what did we have? We had 20 times the sine of 75.5, I think it was, right? So let's see here. Let's drag this off to the side. Where the heck are we? Yeah, it was going to be right. See right there above my mouse, 20 times the sine of 75.5. And that comes out to be 19.36. What does it want me to round to the nearest foot? So 19 feet. So let's put a little dot above our equal sign and put down 19 feet, right? 19 feet. So what's going to change in this problem? Well, now he extends his ladder out to 36 feet. So, get rid of the 20 and put a 36 over there. And so then we go over here and we just have to change this 20 to a 36. All right. So let's do that. And it looks like it's rounding again, 35 this time, right? So now my x is 35. So maybe make a little note, like with 36-foot ladder, we want x to be approximately, what did I just say? 35. Okay, so 35 feet. All right. So, I would put down here like x is between this is going to be a little tricky because I guess we're rounding, right? So, yeah, you can sense my hesitation here, because it wasn't exactly 19. It was 19 something, and we rounded down. I'm not going to worry about the inequality signs, because, geez, what do you put, like an equal here? And it really wasn't exactly 19. So, I'm going to make it like this. I'm going to make it greater than 19 feet unless, I mean, if you're washing a window, you're not so worried about 0.3 of a foot or something, right? So somewhere between 19 and 35 feet is good enough. Now, how does the problem change over here? Well, it says the sun's a 75-degree angle above the horizon. Okay, so let's draw a little right angle here. And you notice how I'm not worried about, does this look like 75 degrees? I'm just drawing a same right triangle that I had before, right? And this is where our flagpole is. So, maybe draw a little flag up here. And then it says the shadow is 17.2 feet. This is where the shadow would be, right? And so we'd like to know, well, how tall is the flagpole? So this time we have the opposite leg and we have the adjacent leg, because the adjacent leg, these are legs make the right angle, right? So the adjacent leg is the one that's helping make the angle, that's the acute angle, the 75-degree angle. And so which one has O and A in it? Tangent does, right? So we're going to go tangent of 75 degrees is equal to x all over 17.2, multiply both sides by 17.2. And so let's jam over here and change this guy to, oh my, look at the angle's almost the same from one year to the other. And 17.2, right? Yeah, I got to change this to tangent. Boom, boom, boom. Tan 64, what am I supposed to round to? To the nearest tenth? 64.2? Okay. Oh, wait. Well, that's not going to be my final answer, I don't think, because it didn't ask us how tall the flagpole was. So let's go 64.2. Actually, you know what? I'm not going to round that. I can round it on my paper to whatever I want to round it to, but I'm going to use as accurate of a number as I can, because remember, we're doing more work with this, because now it says when the sun sinks to 65 degrees, how long's the shadow? So, I don't know. I guess make another drawing. So now the shadow is going to be a little bit longer. The flagpole is still 64.2 feet tall. Again, do not use this rounded number in this calculation. We're going to use as accurate answer as we can from Desmos. So now it's down to 65 degrees. So we want to know what this length is right down here. Is maybe I'll call it S is kind of a weird one to use because sometimes it looks like a 5, but I'm going to do it anyways. And so if we have the tangent of 65 equals 64.2 over S, this time, like last time we were multiplying both sides by 17.2 because that gets the 17.2 out of the denominator. You'd have to do that on both sides, right? Multiply both sides by S, and then you would divide by the tangent of 65. We said that this is one situation where you can think about tangent 65 and S switching locations in the proportion. And you might say, well, that there's no proportion here, Nelson. I don't see what you're talking about. Well, you can think of tangent 65 over 1, right? So you got a ratio equal to a ratio, and you can switch these two because it's an equivalent proportion, or it's still a proportion. So we want 64.2 divided by tangent 65, and I really want that answer right there. And so what did we say? We're going to divide it by tangent 65. So I just put parentheses around this stuff because this is my answer from above, and then tangent 65 right there. And excuse me, the shadow is 29.9 feet long. So I would put 29.9 feet right in here, 29.9 feet. If you used a rounded number like 64.2, let's see what would happen if I got rid of this thing and if I put 64.2 there, 64.2, does that change my, it's still to the tenths place. It's still good enough, right? Or worse, like if somebody rounded to 60, now you'd be off. You might say, not a big deal, Nelson. Yeah, you probably get a 5 out of 6 if you did something crazy like that. But who would do something like that, round it to 64? Man, I hope I'm making this clear. SOHCAHTOA, right? We got another SOHCAHTOA problem over here. It says straight stretch of mountain highway, 5 degree. I'm not going to draw a 5-degree angle. Heck with that. So I'm just going to draw my right angle right here. I'm going to put 5 degrees down. And then it says if you drive a distance of 12 miles, well, 12 would be right over here, right? Because you're driving along this highway that goes up a slope. How far do you descend? Oh, I guess we're driving down it. Sorry. How far do you descend vertically? So that would be this length right over here. This is another sine problem, right? Sine of 5 degrees equals x over 12. Multiply both sides by 12. So we got 12 times the sine of 5 degrees equals x. Hey, folks, I know you can do this. You have all the people in this room to help you out. If I'm not making this clear, ask for some help. Hey, I love you guys. I know you can do it. Thanks for watching my video.